Okay, our last video for the week, determinants and inverses. So determinants are something very specific to matrices, but inverses we should be familiar with. So in multiplication, for example, if I have 2 times 1/2, I get 1. So 1/2 is the multiplicative inverse of 2. They together multiply to 1, which is an identity. In adding, 2 and -2 would be inverses because they add to 0. So inverses are just kind of the opposite of what we currently have. So in matrices, an inverse is a matrix that multiplies with another matrix to get the identity. So we can see that right here. So if two matrices multiply together to get the identity matrix, which we talked about just has some zeros and ones in it, then that is the inverse. So to calculate an inverse of a matrix, we have to find something called the determinant, which is just this little formula right here using A, B, C, D from the matrix as it's written there. So we're going to do some of this by hand. We're going to do a lot of this with a calculator. It looks a little confusing at first, but we're going to go through this first one starting step by step here by hand. So find the inverse matrix, A inverse. That -1 we would just kind of read as inverse. So A inverse is 1 over AD minus BC. So I'm going to start with that before we get to all this part. AD minus BC. So A, B, C, D is how we're going to label those. So AD would be 3 times -1 minus 2 times 1. And we have to multiply before we subtract. So I'm just going to throw parentheses around there. -3 minus 2, we get -5. All right. So continuing on here, I'm just going to kind of put a little box around this. 1 over this answer we got, -5, times, and this is where some things switch around. So A and D switch, and B and C become negative. So the -1 is here now, the 3 is here now, and now these are both negative. All right, so now, as we saw in the last video, we are just going to multiply this -1/5 by every element. So I'm just going to distribute the fraction -1/5. So -1 over -1/5 is +1/5. +2/5. I'm going to make these bigger. +1/5. -3/5. So this right here is the inverse of A. All right, so we are going to use that on the calculator. Just kind of getting ready for the next step here. We want to show that A times A1 equals the identity, and that inverse A times A equals the identity. So just a reminder, the identity is a square matrix, so a 2 by 2, that has ones along the diagonal starting with the first spot and zeros in all the other spots. So if I get this as my answer when I'm multiplying, then we've correctly found the inverse here. So I am going to go to the calculator now. This is that desmos.com/matrix. And I do need to save A. So new matrix, 2 by 2. A is 3, 2, 1, -1. And I'm just going to hit enter. You'll notice there is an inverse button here. This one is using decimals, But if we kind of compare, so 1/5 is 0.2. So these were both 1/5 in this first column. 2/5 is 0.4, and negative 3/5 is that negative 0.6. So we did get the exact same matrix for our inverse. Now I just want to show that A times its inverse equals 1, 0, 0, 1. So if you're looking at this, you're like, that number, this number right here, this negative 2.77, that's not 0. But notice it's times 10 to the negative 17th. So it is 0.17 zeros and then a 2. So this happens sometimes on calculators where there's some number so teeny tiny that they don't want to call it 0, but for our purposes, that will be 0. So I know that looks weird, but we can think of this as 1, 0, 0, 1. And then I do want to show it the other way as well. So inverse A times A. And same idea again. We have this number that we want it to be a 0, and it essentially is. So it is 0.1705. And so that small of a number we are going to consider 0. Yeah, so that is an inverse. For our purposes, like we can say we did get these. I know we got some weird numbers for these zeros, but I'm glad we kind of saw it here in the video so that if you see it in your homework, you'll know that that can happen. It's okay. And then we are going to move on to the 3x3s. So 2x2s, we were able to find the inverse by hand. A 3x3, that is really just not going to happen. Not in the level of math we're doing at this course. So we're going to use that calculator again. So I'm going to go back onto the calculator and find what is the inverse of A. All right. I'm going to clear this all out of here. I'm going to make a new A that's 3x3 and plug in what we got here. So 1, -1, and just filling this all in. All right, I'm just checking that I wrote everything down right. I'm gonna hit enter. So inverse A, this is what we've got. We've got some decimals in there, but they're not too bad. So this is our inverse matrix. I'm just going to write this down in our notes. So the inverse of A .25 and 0.75. And then we're just going to look and verify that both directions of multiplication, we get the identity. So the identity for a 3x3, we have 1s along the diagonals, 0s everywhere else. All right, so A times A inverse. And this one, nice, we did not get any of those weird zeros. That is the identity. A inverse times A, same thing. And if you're wondering why we have to do it twice, why we have to do it both ways, remember from the last video, the last video, multiplying matrices, that you can get different answers depending on the order. So we want to verify no matter which order we're getting the identity. All right, so that is our last video. Next week, we are going to tie this back into the systems of equations and how we can use matrices to solve larger systems of equations. All right, thanks.